Hey y'all, let's do some more triangle proofs. Also, my cat's really needy right now, so he might get involved with teaching us to us. I don't know. Okay, so we're doing triangle proofs part 2, which means I'm unlocking new cards for you. The first card we're unlocking today is hypotenuse-leg, or HL. So let's talk about it. Hold on, let me rearrange this screen. Just give me a second. Not perfect, but it works. Oops. Okay, there we go. Not perfect, but it works. So here's hypotenuse-leg. Hypotenuse-leg is the only time you can use the angle side side, the swearing theorem. It's the only time you can do that. Here's where it is. So here's my angle, and here's my side, and here's my side. It has to be a 90-degree angle. The reason is the Pythagorean theorem. If I have a 90-degree angle and I have two sides that match, then the third one will be the same as the other third one because of the Pythagorean theorem. We don't need to go through the entire proof of it, but in this specific case, you can use the angle side side, but you don't say that. You call it hypotenuse leg because that's what clarifies that it is a 90-degree triangle. I'm going to show you an example on my notes in a second, but let's also talk about isosceles triangles. So here's the isosceles triangle theorem. Don't get caught up on this stuff, okay? So the isosceles triangle theorem says that if two of the sides are the same, then the angles are the same. Okay? Sides means that the angles match. If you want to go the other way, if you want to say that the two angles are the same so the sides match, you use the converse of the isosceles triangle theorem. So I made a little graphic over on the screen where I go, okay, sides to angles is the isosceles triangle theorem. Angles to sides is the converse of the isosceles triangle theorem. Okay, so if I know that BA and BC match, then A and C are the same. If I wanted to go the other way, I would say that A and C match, so that way BA equals BC. That's the converse of the isosceles triangle theorem, which is a lot. I know, I know that's a lot. So I'm actually, I'll do that soon. I might change this to be the shortened version because usually we say ISOS for isosceles, we shorten it. And then triangle, you can use the triangle shape, the delta. So that's the shortened version of it, so that we don't have to write out the whole thing on there. But those are the two things that we've unlocked. Also, I do not want you to forget about parallel lines. So if I go back to my angles, yeah, all of these are still active. They're still legit. They're still necessary sometimes. So if I ever have a triangle where, hold on. Okay, if I ever have a triangle with parallel lines involved, I probably want to use one of these to have something about the angles. So for instance, in this case, because these are parallel, I can prove that this top angle and that bottom angle are equal to each other because they are alternate interior angles. So I almost clicked on the wrong thing. Don't forget that these are all things that we can use. Yeah, it looks kind of funny because it's in a triangle shape, but it's basically just two parallel lines with two transversals. So if I just focus on this one, then that angle and that angle are the same. And if I focus on the other one, then this angle and this angle are the same. That is alternate interior angles. That's really the only one you're going to use, to be honest. There's not a whole lot of alternate exterior angles involved with triangles, but this one is a huge one that you're going to want to use. Okay, so let's go back to our notes. Hey, that was clean. So I'm going to go back to my triangle proofs. Let's do at least 2 examples, if not more. But I wanted to do that whole thing where I walk through the proof cards with you so that way you at least know that those are important too. Okay, so let's get started. Okay, so here's our first proof. I'm grabbing some Mardi Gras colors because it's the middle of October, so why not? That has nothing to do with it itself. Okay, but I wanted to color code this a little bit so I can show you where all this information is coming from. So BD bisects AC. That's one of the statements that's given. What does that mean? If it's bisects, that means it cuts it in half, right? So that tells me that AC is cut in half, which means that this side and this side are equal. So that's my first step. Second, BD is perpendicular to AC. That's what this symbol means. Actually, let me write that up here. Perpendicular. Yes, I swore a little bit. No, don't fire me. Okay, so if BD is perpendicular to AC, that means that this is 90 degrees and this is 90 degrees. That's just what perpendicular means, right? It intersects at 90 degrees. So we're going to use the definition of perpendicular to make that statement the case. Because we have to say that this is perpendicular and then we have to say that those are 90 degrees. And then we have to say that they're the same because they're 90 degrees, but we'll get there. Okay, and then finally, there's one other hidden one in here that I'm hoping by now you recognize right away. This side is the same. That's reflexive, right? BD is the same as itself. Of course I chose yellow. No, you can't see yellow. Yuck. It's reflexive. I'll try to fix it when I take the picture. Some y'all don't read these, and that's okay. Okay, and then I technically have angle, sorry, I technically have side angle side. Oh, this doesn't even work for hypotenuse leg. I'll do another one that works for hypotenuse leg. For hypotenuse leg, I need the hypotenuse, which is the longest one, and a leg. So this one's actually just angle side angle. Oh well. Okay, let's do it. So statement justification. I might do 2 pages. It's fine. Would you, I can't ask you this ahead of time because you're going to see this after I finish, but I wonder if you'd rather have 2 than less. Okay, so BD bisects. This looks familiar. Maybe I did this already. And then BD is perpendicular to AC. Those are both given. Okay, and then because BD is perpendicular to AC, that means that angle ADB is 90 degrees. And that's the definition of perpendicular. See how I just used the symbol again? It's the same. And then angle BDC is also 90 degrees. Which means that those 2 angles are congruent, right? Angle ABD is equal to angle BDC. That is transitive. Property of equality. If it had an inequality, or sorry, if it had a congruent symbol in it, it would be the other one. Substitute, or transitive property of congruence. So, but this is an equal sign, so it's fine. Okay, so we have 2 angles that are the same. I technically have to say right here that ABD is congruent to BDC. I'm not going to do that because it seems silly. You know how this works. All right, and then BD is congruent to BD. That's reflexive because it's the same as itself. So, oh, and then I forgot to actually say that AD is congruent to DC. I forgot to say that, but it was from bisect, so that's the definition of bisects. Somebody asked me in class if it's okay if they're kind of in a weird order. Yeah, I could have put this anywhere after this statement. So if I want to clean this up a little bit, maybe I would put this directly after this one. So because it follows logically that bisects means it's congruent over here. But it can go in any order as long as the statement that created it is on top of the other one. That sounded weird. Okay, and then I have triangle bad is congruent to triangle bacad. I don't know. Okay, and that I said was side angle side. Y'all, I tried making one up that had the other thing in it. Oops. Okay, let me see if I can actually do this right this time. Y'all, I'm embarrassed by the amount of white that I had to use for this. I did a different triangle and I wanted to fix it, so I did some white out and I had to do some more white out. And anyways, okay, so what we're going to do is try to write on this with my freaking markers. Okay, so we're given that MON and POM are right angle, or right. Y'all, I already messed up over here too. Right angles. I got excited about the triangle part. Okay, so what that means is that we have this angle and this angle, right? They're both right angles. And we're also given that N to O is congruent to M to P. So this line right here and this line right here are the same. Not the little parts, but the big parts. And I want to make that clear, but I can't do it overall. Anyways, and we know that this is the same as itself, right? We know that's reflexive. Even if it's not shared between the triangles, it's at the bottom and they both have it. So, okay, let's get started. So here's my statement and my justification. Should add a proof card for this one. Okay, so MON and POM are, okay, we say right angles. RT is right. The justification for that is given. Okay, now watch this. They're right angles. I'm going to skip a bunch of steps. And I'm going to actually make this a proof card because I haven't yet, but I should. MON is congruent to PON, and the justification for this, you won't believe it, is all right angles are congruent. I do need to make that because it is legit. It doesn't sound legit. Okay, and finally, not finally, NO and MP are congruent. That was given to us. And then we know that MO is congruent to OM. And I'm just switching the letters around because it's flipped on the triangle, but it doesn't really matter. That's reflexive property. And so then I have these two triangles are the same because of hypotenuse-leg. Because I have, I have two right triangles, and I have the hypotenuse is the same and a leg is the same. I actually probably didn't even need to say that these were congruent, but it's fine. I don't care. Okay. Good gravy. I wanted to do one about isosceles triangles too. Actually, let me go back to the top here. I easily could have told you that A and C were the same. That would have told you that these two sides were the same. Okay, so if these two bottom ones match, then the two top ones match. And let's remember which way that goes. Not that one. I just missed the thing a little bit. So if I know the sides and it gives me the angles, that's the isosceles triangle theorem. If I know the angles and it gives me the sides, that's the converse of the isosceles triangle theorem. Those of you who just look at the notes, who is not you because you're watching this, won't understand. I forgot my tombstone. There we go, I fixed it. We're going to do more practice in class. We're going to start doing slidey droppy things. I'm going to actually make them pictures instead of things because I know it confuses you. But I got you. Great. I hope that helped. I sure hope that helped. And I will see you in class. Okay, bye.